Well, good morning from the workshop. We're here again. It's where are we now? 19th of November 23. No motorcycle stuff today or other engineering doings. What we're doing is I've had a little project that I've been kicking around for a while now. More aircraft stuff from East Kirkby, basically, and it's the vacuum pump. So why do we need a vacuum pump on an aeroplane? Well, as I might have mentioned in the past, a lot of the flight instruments like the artificial horizon, the directional gyro, slip and turn, and a couple of others whose names slip me at the moment, are all run off a vacuum of 3 inches of mercury, right? 3 to 4 inches of mercury, somewhere around about there. And this is done by a vacuum pump off the back of the Merlins. And so I've got all the documents here. I've got all the stuff. It took me a while to find this because it was hidden in archive documents. So what I'm referencing to here is AP 105C-0902-1. And what we're interested in is a vacuum pump. It's a type B3. It'll run in either direction, clockwise or anti-clockwise, and it gives 6 inches of mercury inlet depression at 2000 RPM, and it goes on and on. So we're not going to be running this at 2000 RPM. Looking at my sheet, we're going to be running it at 400, because at 1000 RPM you can't hear yourself think. Yeah, you'll see when we've got it running. What I'll do is I'll show you my little rig. It's a little bit ad hoc. It's not as it is in the documents because I don't have manometers. All I have is a gauge that gives me sort of inches of mercury, and there's a bottle to even out any pulsing. And so without more waffle, let's get on with it, and I'll show you what we've got back there. So what we've got here, there's the vacuum pump there. Okay, it's mounted to a homemade bracket. Right, so this would mount to the back of the engine. We've got a homemade quill shaft there. Now the original standard quill shaft would be splined at one end to fit into the gearbox, and it would have an Oldham coupling. We haven't got one, so what I've done is, let me just I won't take it off now, otherwise that will spoil what we're doing. But yeah, so I've made up my own quill shaft. It's wasted in the middle to give us a little bit of flexibility, and I'm running it off the lathe because we don't have anything big enough at the Heritage Centre to run this, because it does take a bit, and of course as you bring in sort of the vacuum on, you're creating quite a lot of work for this to do, and it does put some effort into the motor. So we've got a 3 horsepower motor, a 3/4 horsepower motor down there, and it's geared up to run this. So that's running at about 1000 RPM, and this is geared to run at 400. So there's a multiplier there. Let me just get a cloth to wipe the grease off my mitts. At the back there, okay, coming out on this pipe here. At the back there, I've got a standard air cylinder. Yeah, anyone who's worked on RAF aircraft or any military aircraft will possibly recognise that kind of thing. It takes up quite a high pressure. The reason I've got that is this is pulsing. Yeah, there's 4 veins in there, so it's going pop. You'll hear it when it goes. It's pulsing, and I just wanted to even out the pulses. Yeah, for the measurement. And then off, that's coming down on this blue pipe to this gauge here. Just bring that down to that gauge there, and there's a little tap here that I can control the airflow. At the moment it's wide open, so there'll be nothing on the gauge. So this is going to get noisy. Right, I'll turn it on, put that back up there. We'll turn it on and see what you think. I might have to voice over this because it might be a bit too noisy, but we'll give it a go. Okay, so what we've got now, right, think this is serviceable. Let's try that again. So I think this is serviceable. I shall take it off shortly because I've got another job to go in here today, and yeah, so this will be ready for testing on the aircraft. Like I say, we can't test it here, but I think because this will quite happily do 10 inches of mercury and over, which is quite a fair bit of suck, I think it'll do just nicely. Like I say, it'll quite happily, by the looks of it, run all the instruments at 4 inches of mercury, which is what we want, and that should be that. So so what I'll do, before I go any further, I'll show you the quill shaft. Yeah, now we've done the test, I'll show you the quill shaft. I'll just have to wind this off. Now, the input shaft has a groove in it that would accept a pin from the Oldham coupling, but like I said, we haven't got an Oldham coupling, and I did think about making one, but I thought it might make a bit too much noise. So let's move that back up there. So okay. So basically, what we've got is this. Yeah, that's the drive end. Yeah, there is a little bit of play in there, not a lot, but just enough. Yeah, it's weighted down to give us a little bit of flex on the shaft, and as you can see, that was being held in the chuck. Yeah, it did the trick. So there we go. Quite simple. I shall take that in tomorrow and sign it up as serviceable, subject to aircraft fit and test. Yeah, because as far as I'm concerned, it works. It's working according to the manual. We're getting plenty of vacuum out of it, or plenty of suck, call it what you will, because we're not producing a vacuum as such. I'm quite sure. Yeah, we're just lowering the air pressure by 3 inches of mercury, basically, and that's causing the machines to, or the instruments to work. So there we go. So yeah, homemade quill shaft, homemade bracket, and it's a good one. So I shall go through the rest that we've got in stock over the next few weeks and get them all done. That would be a bonus, wouldn't it? Yeah, and then I can get back to maybe filming some of the winter maintenance that's going on. So anyway then, without further ado, I'll wrap this lot up and I'll catch you guys later. Do all the good stuff, comment, rate, subscribe, you know, all the usual stuff I asked you to do, and I'll catch you guys later. Stay cool, enjoy the winter.